I'm Markus. I'm from Renumics. I'm founder, co-founder, and CTO of Renumics. And I like my coffee as a latte macchiato, sometimes with vanilla flavor.
Welcome back to another MLOps community podcast. I'm your host, Dimitrios. Today, talking with Markus has been enlightening on the car simulation front. Well, just simulations in general, and how he's been doing some really cool stuff with embeddings. We got into it at the end on how messy this data can be and what's been taking up a ton of his time and why he feels there aren't the right tools for the job when it comes to some of these data pieces that he has. And it's not only for simulations, but just for the immense amount of data that he's been gathering with these use cases that he's working on in partnership with car companies. So we got to geek out a little bit on car companies and roads. And if you're Italian, I mean no harm when I say that you have shitty roads. It's just a fact of life. Also, Greek, I threw you under the bus. Let's be honest. There's some places that have really nice roads. And me living in Germany, I'm going to look down on all of you that do not have the nice roads, because Germany's got some nice roads. I'm going to give it up to Holland. Holland, they might have some of the best roads in all of Europe. They spend a lot of money, and those roads are super smooth. All right, let's get into this conversation already. Enough about them roads. If you like it, share it with one friend, please. All right, real quick, I want to tell you about our virtual conference that's coming up on September 12th. This time we are going against the grain, and we are doing it all about data engineering for ML and AI. You're not going to hear rag talks, but you are going to hear very valuable talks. We've got some incredible guests and speakers lined up. You know how we do it for these virtual conferences. It's going to be a blast. Check it out right now. You can go to home.MLOps.community and register. Let's get back into the show. And let's just start from square one. What are you up to these days?
Currently, I'm working on getting our company compliant. So I'm CTO. So my role actually is to take care of scalability at the correct time and correct level in the project. And currently we are working on getting some certificate for our projects, and that's what I am working at the moment at the most. But aside, I'm also working on a lot of projects. For example, I worked very hard and had a lot of fun working on it for visualization for RAG. So I applied UMAP and other visualization techniques for RAG to give the possibility to take a deeper look with visualization into RAG data on the document side, but also on the query side. And I published that towards data science.
Visualizing the embeddings?
Yeah, I visualized the embeddings. So I reduced the embeddings using UMAP to a two-dimensional map. And this helps a lot when you try to get a good overview over your data. So you can see forming clusters of different topics, for example, or you can find a lot of time you can find some anomalies where you see that you have included some text that you actually didn't want to be in your database. For example, in this demo I wrote, I thought that Wikipedia footer and header texts were also included in the database, and they popped up like little clusters with a lot of points, and I solved that only because I was using this the visualization technique.
And you're exploring the data sets through this visualization, basically the embeddings visualization on I think it's a 3D graph, right? And so you can see
a lot. But a lot of people are using a 3D graph, so they reduce the high dimensionality of like, I think, almost 1,000 dimensions to 3 dimensions. But I prefer to use a 2D presentation because that is a little bit easier to overview. It's reduced more, so maybe you can see a little bit less, but it's much easier to present. So if you are creating slides for it or show someone a specific cluster, it's much easier from my perspective if you have reduced it to 2D, because you can use a plain image and it's very hard to represent the 3D graphics in a presentation or in a team and work together on it on the team. That's a little bit harder. But yeah, I use this 2-dimensional map, a lot of points on it, and check out the different clusters, look for clusters that are somewhere outside the other clusters and check is this expected? What's going on there? Is this data that's actually useful, or is this some anomaly? And it gets even more interesting if you include then the question with it. So you can, for example, project the question in the same space, all your questions, reference questions, or questions from your users to find out which part of your document space is, for example, important for your users, or is important when you evaluate your model. So you can find, for example, also where are clusters in your documents that are not covered by your reference questions for your evaluation, and then you can think about it and maybe add more questions, or maybe this cluster isn't not that relevant and you can drop it from your document store.
And if I'm understanding this correctly, you're also creating embeddings for the questions, or you're just looking at which embeddings the questions are pointing to?
Yeah, you can use both. Usually you embed the question to find the relevant documents for this question. So you often have a embedding for a question, but yes, of course, it's also very important to find that actually the nearest neighbor of this question in the embedding space, which are the documents that are relevant for this question. Maybe the 5 or 20 next neighbors are usually taken into account when answering the question.
And then you're getting a better idea of what documents are getting high usage and what documents are lower usage.
Exactly. You can maybe use that to color your similarity map, so you can see how often the documents are used or referenced by questions, and color code that to find some kind of a heat map and see what area in your embedding space is important or is referenced a lot and which is not.
And so how have you been using this? Like, what are you able to do once you have this heat map, or once you know that the documents are being used more frequently? What do you do with that information?
I think the most interesting part for me at the moment was to see how the project evaluation questions are represented there. I have seen a lot of cases where the reference questions only span a very limited area in the embedding space, and there are other documents in the space, and it's then very important to talk to the customer or whoever is interested in the data. Is here something missing? Do we don't need the data, or should we try to add new questions? So I think that the coverage idea for the reference question is very, very important. It's a very efficient step in a project to get a better understanding for the expectation of the customer. And maybe then I haven't used it yet for in production to see how it works out with the questions of the end users, to see what documents are important for them. But yes, that's also a very interesting point. You could use that to optimize your model or to optimize the whole approach or to reduce the data for the use case based on this
Yes.
information, how it's actually used, and maybe also compare the reference questions that you have worked out with the customer and compare it against the questions that are really asked by the users in the end system.
Yeah, you're able to figure out what are those 20% of the documents that are getting 80% of the queries.
Yeah.
And really make sure those are pristine. I also like this idea of, as you're building a product, you gain insights into what the expectations of your users are.
Yeah.
So this visualization is going to help you see in a different way this data that is coming through as people are interacting with your RAG.
And I think also what is important to also collect information from the maybe the customer or in the end the user, how good the results of the RAG system were for specific questions, to get this feedback and also use this feedback in a visualization again to maybe find then areas or clusters in the document space where the system doesn't work as expected. So not only to find which is covered, but also find out which cluster in the document space has which quality level based on the feedback.
So you're taking it a step further. It's not just what questions are coming through, what documents are relevant, what are the best ways to answer these questions, but also what is the actual output, and then using some kind of evaluation criteria on top of that and being able to see what the output was and visualize it differently than just a bunch of question-answer pairs.
Yeah, exactly. And I think the important step is not to use some automatic measurements or criterias, but real user feedback. So we always try to include very early in our projects some feedback mechanism for the users. Is this answer good or bad? Why should we discuss maybe this answer again together with you? I think that's much more important than using some RAG metrics to decide if the quality is okay.
Yeah. So this, just so everybody knows, this is an open source project, right? We can all go and download this and start playing around with it today.
We have different projects. So we have Spotlight. Spotlight is our tool that we use to look into different kind of data. So it has support for 3D data, like 3D meshes. That's where we actually come from. We did a lot of development for simulation engineering. So that's supported there, and video and audio and images, but also text. And it has support for visualization of embeddings as a UMAP, and you can use different embeddings and visualize, for example, also RAG data and visualize the questions in the embedding space and the documents in the embedding space. And that's what I have written about at Turbo Data Science a few months ago. And you can check it out. It's all open source, and there's also a RAG project from us, which includes some limited, very simple RAG techniques. It's a vanilla RAG, and it doesn't include the feedback mechanisms actually, but you can use it for basic projects and visualize embeddings of documents and questions with it. It's in this article.
But it's not only for RAG, right? You can also do classifications, or is Spotlight specifically for RAG?
So Spotlight is specifically for, I would say, machine learning data. So it has support for text, has support for images, videos, a lot of audio, because we have customers that use it for audio, and also for 3D animations. Actually, we used it for exploration and classification of simulation data of car crashes.
Oh wow!
So where you can compare the end result of a car crash based on similarity of the deformation, for example. But that's something you have to prepare in the project. So the idea of Spotlight is only to visualize 3 different kinds of data, like 3D data or audio or images and a lot of different stuff, but together with embeddings. And you can use this embeddings to create some kind of a similarity map, and then you can use the similarity map to browse or go through your data. You can zoom in, select a specific point, which can be, for example, the result of a car crash, and then you can compare 2 points in the similarity map that are next to each other by visualizing the actual simulation, so like the 3D animation of the car crash. So the idea is to have a tool that combines the machine learning view of the data, like UMAP or statistics of the individual of each point in the data set, but also have the possibility to very deep zoom into each point to find out what the actual difference is. So it's the idea to bring the machine learning engineer on the same page together with the domain expert, for example, a simulation engineer for our cases.
Okay. And let's talk a little bit more about the simulation engine, because this is fascinating to me. The idea of creating a 3D space and then simulating car crashes and creating embeddings out of those simulations so you can know which car crashes failed in which ways and similar ways. And if you wanted to then search for failures or car crashes, I guess you could search through the embedding space.
Yep, that's the idea. So if it works well, you have to do some work to get these embeddings. It's not the best idea to just take the whole animation and the whole part or the whole car into the embedding space, but often very easy to just define this is our region of interest, defined by maybe this 1,000 points, and use this 1,000 points to create the embedding for this area of the mesh, and then you can cluster the result of the simulations using a UMAP, for example, based on the embeddings, and find clusters of similar defects where the results of the car crash were very similar, and maybe you can find some outliers when you have found a very, very good configuration for some material. So that's the idea.
This is working with car companies on testing new materials or testing new designs?
Yeah, that's a use case for that, for example. It's something we don't have this specific case I'm now talking about in a customer use case, but that's a showcase from us. And there are people that work like that, not with Spotlight all of them, but some of them. But there are, of course, also different areas. We have a lot of projects in this in the engineering space of car companies. This starts with maybe this simulation post-processing, where you can organize the results using embeddings, but also in the, for example, pre-processing of the simulation, there's a lot of manual work to do. For example, you have to define how, if you combine hundreds or thousands of parts together in a simulation, how these are connected, and you do not only always have the the information how these parts are connected. You have to look into and compare it. Okay, this is part A, this is part B, and this is usually with connected with this kind of connection. And we have in a very early or in a very old project now, we had built a classifier that automatically detects the different parts and gets the idea what the connection of this part should be, and then the engineer can use this tool to create hundreds of connections automatically and review it afterwards, and then use this in a simulation.
Oh, nice.
And
so this is it. Again, going to this specific use case, it is basically so that when someone is creating a new style of connections or new parts in a car, they're able to keep that going so that the simulation can understand how the dynamics would be and how physics would work with that? Or is it so that the next person who comes and tries to do stuff with it knows the way that those parts were put together?
In this project, it was about creating the correct representation for the simulation. For example, if you have maybe a screw in reality, you would in the simulation just tie the points where the screw actually would be together using a constraint. So we wouldn't model the connection itself as how it really is, but with a very simple model. And you can have a catalog of this simple models and train a classifier to find in which situations this connectors are the correct ones to take and model that up.
I've got to come clean with you. I absolutely am addicted to these simulation videos on TikTok when you watch, but only when you get somebody good that's giving like a really nice voiceover and they're making it really funny, because you have different cars getting smashed by semi-trucks and it's like, would you survive? And then you have people giving voiceovers that are hilarious, but for the most part, you're not surviving when you're getting hit by a semi-truck. That's the key takeaway there, as if people didn't know that one already. But so let's talk more about what some of the other pieces that you have been working on are. What some like cool use cases that you've been seeing out there are.
A very cool use case for us at the moment is the evaluation of test data. So if you build, for example, a car, then you test it on test tracks with test drivers, and you get a lot of results. And it's very hard to get all the results into a representation that really allows you to find anomalies very easily, or find good setups, or find errors. It's actually, I think, at the moment, a lot of manual work. You have an expert that has to go to a lot of data.
And that's just because there's so much data that you're getting?
Yeah, it's so much data, so it's a lot of work to do. And I think the tools are not that good how they could be actually from a machine learning engineer perspective. So yeah, we are currently working on projects where we use anomaly detection or classification to classify bad behaviors, or errors during the test drive of cars, where we can use automatic approaches and reduce the time that is necessary to actually review the data.
Mm-hmm. And so this is basically like, well, you and I are both in Germany, so let's take some German cars, right? We'll go with Porsche, just cause. So this is Porsche saying, we've got a real car with a real driver. We're going to go take it onto the track that has a lot of different styles of roads. It's got the Italian roads with all the bumps in it. It's got the German roads with the smooth sailing where you can go on the Autobahn 200 kilometers an hour. It's got many different scenarios, maybe dirt roads, whatever.
Yeah.
You have that test drive in real life. We're no longer talking about simulations, right?
Yeah.
So it's in real life. It comes back after, and it probably does various of these. I imagine it's going through and doing many of them, and you're trying to just take it to the limit sometimes, or you're trying to just see how it drives normally and change gears, make sure it does everything that are table stakes well. And then when it gets to those edge cases, see how it performs there. I can see how if you have the minimal amount of sensors on a car, that would just be so much data that you have to sift through and see if there's any kind of anomalies. But now I can only imagine that Porsche has more than the minimal amount of sensors, right? There's probably sensors in everything that you now are looking at, and you're trying to see, is this working properly, or is this working less than properly? Because I imagine if you're a human, you don't necessarily feel if something's off, but you want to make sure that, all right, it works for 10,000 kilometers or 10,000 miles, but we want it to work for 100,000 miles. So we want to be able to catch things early and fast. And now you're trying to sift through the data and see if there's going to be something that breaks. How do you even go about that?
It's very depends on the data that you have already. So of course you have very long records. You have a lot of channels. You have different modalities. You have sensor data for acceleration, for example, or sound, maybe also a camera. So a lot of different data also. And the first thing to do if you set up a project like that is to see, is there historical data that is already labeled? Do we have some data that we can use? Then we can, for example, go for a classifier for specific errors that we have already seen in the past to find them again in the new data. No, actually automatically. Or do we have to, if we don't have the data, then we could go approaches for anomaly detection and find where are some very, very rare cases and look deep into the point in time in all channels and all videos and find out what's going on here. And of course, you have the idea that that I often prefer to do some visualization of it. So you use embeddings for again for the different signals and maybe for the images and for the audio data, and project that into different similarity maps and go for your clusters and find out what's going on in a different cluster. Then you can filter out one cluster if that's not interesting and find out what you end up with being interesting for you. And maybe you can use simple concatenation of the different embeddings from the different modalities into one visualization, or you can use multiple visualizations that are linked together. So you can select on one side the data points based on the audio signal, and on the other side you see, okay, if the cluster of the audio signals also form the subcluster in the different sensor space, and use that together to find some specific clusters again. So you can actually use the embeddings for data exploration. But I think in the real projects at the moment we are focusing on very specific cases to find where we can use classification, or maybe also anomaly detection, for example, to find out that the simplest thing is that something is wrong with your setup. So that's a very common case, just to find out before you start the actual measurement, do some anomaly detection if maybe you have connected your sensor in the wrong way. You have switched to cables.
Oops.
Is that some order?
Yeah. Yeah, I can imagine that happens more than we would like to admit. And it's good to find that early so that you don't waste your time on bad data and you're trying to figure out what's going on here. Why is this data not giving me these answers? And you recognize, okay, well, there was some cable switched, or there was some type of sensor that was broken or whatever.
And one thing that we are currently looking into is the combination of the direct world and this time series data world, so that you can use questions not only for your documents, but also you can include the data by the simple generation of SQL statements maybe, or by code generation, to give also the engineer or the test driver the possibility to explore the data very easily.
Wait, so explain this more, because this seems awesome. So basically you're combining these two worlds, but I didn't quite understand what that entails.
For example, you could ask them the system, which was my best round on the test drive. And the system creates an SQL statement to query this data from the store and find the fastest round.
Oh,
Or
okay.
you can try to find or try to ask more difficult questions, maybe to find what could be the reason for something. I heard something was different than usual. There was an anomalous sound in round 5. What could this be? And then the system can try to bring the relevant data to you.
So it's interacting with the tabular data in natural language.
That's the idea. Maybe by simple SQL statements, maybe by code generation, but the idea is to make the tabular data accessible for test drivers or test engineers, not only for ML or data engineers.
Yeah, so it's that test driver who says, heard when I was going around that 4th lap, there was something that was making a weird sound, or the brakes weren't working as well as I would have hoped. Can you pull up why that could have been? And so then you have that type of, that's very cool.
Yeah, and the big point, I think, is what is then the result of the system. At the moment, maybe you get an answer in text, but I think it would be much better than to get some visualization of the different channels that were relevant for this event, and maybe a highlight of the specific event in these channels, and maybe also the visualization of the whole data point in your similarity map with the UMAP representation.
Yeah.
So not I think that just answering the question with text is okay, but a very good user experience would be that you get then the automatic zoom into the data. That is interesting for you.
Yeah, more than you could ever want, and then you can go and you can use what's relevant to you. So then, now talk to me about how you're seeing multimodal being used, because you mentioned there's audio data, there's visual data, there's also the sensor data, and it feels like all of that is playing a part to give you a much better and robust picture. And so what do these things entail? That's almost like what you were just saying, where at the moment, when you're asking this text to SQL type of question, you're just getting text back as an answer. But in reality, what you really want is all the relevant data. And so talk to me about the multimodality.
I think at the moment, for us, it's the common approach to have different models, so also different embeddings for the different modalities. Maybe it would be in the future also possible to have all the different modalities combined into one model, so trained on the behavior of the car, simultaneously in the signal space, in the audio space, and in the corresponding image space. But at the moment, maybe that's a little bit too tough for us. So I usually try to keep the things simple. So and I prefer to use one model that is specifically trained for audio and use this maybe for embedding the results or for classification. And a second model trained on video or images for the second group of embeddings or classifications again. Of course, for classifications, it would make sense to maybe train a classifier on the combined output of both models, the embeddings actually. That could be a good idea. But yeah, I'm currently not working on one model for all the modalities together, but on different models, each pre-trained on data from the internet and maybe fine-tuned on data from the different projects, but usually specific for one modality, or for audio or other signals, and a different one for images.
Yeah, it feels like the ROI of trying to figure out if one model can rule them all might not be there, especially if you're finding success with each model being very specific to the specific modality.
Yeah,
I could see that.
And I think that the big problem in this domain we are currently working in, an industrial AI domain, is that you can't easily use a pre-trained model that is trained on data from the internet, because the sensor data or the audio data that is relevant in the project is very, very different from the data you can find in internet and the pre-trained models on that data. It is something I think is very, very clear if you look into, for example, image processing. So you get a classifier pre-trained on internet data that's for cats and dogs and persons, or all the large data sets.
Travel
and in
photos,
industry,
food.
And in industry, you then have very, very maybe boring images from production machine where you want to compare products, if they're classify products, if the result looks okay or does have a defect. So that's a very, very different use case than the models are trained on.
So are you creating all your own custom embedding models, or are you fine-tuning different models that already like you're just grabbing base models from Hugging Face and then fine-tuning them?
Both. So usually we try to fine-tune models again on the very different data, but I'm not sure if there's one strategy for us that always works. We always have to figure out what's best for the specific project. It's always different. Sometimes we can have very good results based on pre-trained models, but sometimes it's clear that we have to do a lot of custom fine-tuning or even train from scratch. We also train sometimes models from scratch for specific use case. For example, this detection of part connections for the simulation was completely trained by us without initial weights.
Yeah, it sounds like it can get messy, especially because you're not getting that much data out there on the free internet.
Yeah, exactly. It's also always tough to get enough data in the projects, because there's often a lot of data available, but quality is always challenging. And of course, you often want to have labeled data, and it's rare.
Yeah, that's expensive and rare. Yeah.
So usually we have to set up a label process in the projects at the moment. Not for the rec projects, of course, it's a little bit easier, but in the engineering domain with test data or 3D mesh data, there's always a lot of to do on labeling side.
Well, yeah, it's a little bit counterintuitive because as we were just talking about, you get so much data when you go for a test drive in one of these cars, but then you need to label that data, you need to clean that data, and just one test drive, I imagine, will take you so long to get actual gold standard data from.
Yeah, exactly. And also the data you have is often packed into different systems based on the measurement. For example, for your sensor, maybe you have the data in a different subsystem than for your audio data, because it's the device is from a different vendor. So you have to combine the signals again. And you have maybe to resynchronize them, because you don't know how to align them.
No. Wait, so what do you do there? Because I just think about when I make music and I have two microphones, I clap so that I can easily synchronize them after the fact in post-production, but I don't see you going before a test drive and clapping so that you can easily synchronize them.
Yeah, you have to do something like that to get them synchronized, or maybe you can try to have some really good clocks. So for where you can use the timestamps for the synchronization, or you can, if you don't have that, then you can go for specific events where you can use to rearrange the signals, because often you also not only have the mismatch between them, we also have a drift. So because the frequencies of the measurements are not perfect in real world sometimes, and then you have to do this not only in the beginning but again and again.
Yeah, and so that feels like just a whole lot of time that you're spending trying to get that data so that it's synchronized, and then you label it, and then maybe you can do something with it.
And a different problem usually that is occurring is also that you have not always a good standardization of the test drive. So you have different test drives with signals and maybe some different captions for the signals, and you have to combine this all into, if you want to train from it, into some data set that is standardized. And this can also be very challenging if you have recorded that for a long time. That's actually something we also want to try using LLMs. So to find out which is the current name of the channel and what could be the last name in maybe the test drive from 5 years ago, to do this matching, which column has what meaning, is something we try to figure out with LLMs at the moment.
Yeah, it's like, hey, given these attributes, given this type of data, given this last data set, give us your best guess.
Yeah, exactly. And if that doesn't work out, maybe also by comparing the data, looking what ends up with similar embedding results, for example. So based on similarity, you can try to do this match just to get a good representation in the beginning of the data set.
Yeah, so now I'm understanding more clearly and vividly why you were mentioning at the beginning of this conversation how you felt like there weren't proper tools in place for this type of thing. It feels like you're probably doing a lot of stuff manually. It's taking you a ton of time. There's a bit of pain, whether it's the types of data being unsynchronized or coming from different vendors. So the sensors are going to be completely different. You have that data drift, and being able to get that data in order is the first step before you can even think about any of this other cool stuff that you're doing with it and the embeddings and all that fun stuff. You got to just get that data in order.
Yeah. Usually we try to focus on specific questions in the project. So we and we only have to clean up the data for the specific use case. So I don't think it's a good idea to start with cleaning up the data until it's perfect, but try to clean up the data and get all the data you need for a specific use case, like a classification for a very specific thing in the data. Because if you try to get the perfect data in the beginning, maybe you take a lot of time to create a very good data set. And I think often you don't know enough how the perfect data set would look like until you start trying to use it, for example, by training for a classifier and using this classifier also. So I think it's very important to go through the whole steps of the project, through the whole pipeline very fast, and then iterate at the beginning again. So don't create a perfect data set, but just give it a start and use it and find what is the real problem in the data set and fix that, because you can't fix all the problems there.
So that's fun to think about. It's taking that same mentality of having an MVP.
Yeah.
And I think I've heard somewhere someone saying, if you're not embarrassed by your first version of your product, you waited too long to ship. And so you're saying, hey, just get something for one use case so you can start to understand what the data should look like, and then slowly expand your use cases. And by the time that you have more and more use cases, then you'll understand what the larger corpus of data should look like. Because if you aren't doing it use case driven, you are at risk of spending a lot of time to curate that data in a way that isn't going to be useful for the use case.
Yeah. And maybe also that I think very important point is that maybe in the beginning you don't even understand the use case. I think it's very important to close the loop to get an understanding what the customer or the user actually need in the end. That's also true for our rack project at the moment. We usually start with vanilla rack, with a very simple rack system, just to that can be implemented in a few days or a few weeks, and then give it to the customer and look how they use it, what questions are being asked, and then we can try to optimize and do some multi-step rack or all the fancy stuff you can use to increase the quality. But we really start with a vanilla rack.
Yeah.
Keep it simple and fast.
Get something out there fast, see what is hitting, and then learn and iterate from there. It's a great strategy for doing that. I also like that. I think you can do that with just about anything. And if you are coming into it with that mindset of, let's just test and iterate and test and iterate, and eventually we're going to start to hit the direction that we want to be going in. Or as I've heard other people put it, it's almost like in the beginning, you don't have to know exactly where you want to go. You just want to be directionally correct.
Yeah.
So as long as you're moving in the right direction, you're good.
All right, real quick question for you. Are you a Microsoft Fabric user? Well, if you are, you are in luck, because we are introducing SAS Decision Builder. It's a decision intelligence solution that is so good, it makes your models useful. Because let's face it, your data means nothing unless you use it to drive business outcomes. It's something we say time and time again on this very show. But wait, what do you mean by nothing? Well, SAS Decision Builder integrates seamlessly with Microsoft Fabric to create effortless business intelligent flows. It's like having a team of geniuses you manage in your pocket without all that awkward small talk. With Decision Builder, you'll turn data into insights faster than brewing a double espresso. And you know how much we like coffee on this show. Visually construct decision strategies, align your business, and call external language models. Leverage Decision Builder to intuitively flex your data models and other capabilities at breakneck speeds. There's use cases for every industry, including finance, retail, education, and customer service. So stop making decisions in the dark turn the lights on with SAS Decision Builder. Yes, I did just make that joke. Watch your business shine. SAS Decision Builder, because your business deserves better than guesswork. Want to be one of the first to experience the future of decisions? Well, sign up now for our exclusive preview. Visit SAS.com/fabric or click the link below.
Well, this has been awesome, man. I appreciate you coming on here and taking the time to have a second conversation with me, because our first one didn't get recorded, but I'm just lucky because I get to chat with you 2 times now instead of 1.
Yeah, thanks for the invitation.